Lay your markers and erasers, and we'll get to that. All right, let's get some warm up here. We might not do all of these. Let's see, I don't need that. I need this right here. All right, guys, let's get focused. Let's start with this one right here. Okay, go ahead and rewrite that the other way. Go ahead and check it with multiplication if you get a chance. Okay, let me jump in here, and if you're finishing up, that's fine. But I can't get a group of 7 out of 3, so I'm going to need to look at 34. How many 7s can I, what's the most 7s I can take out of 34? I've got to take the most out. That's going to help me later on down into the problem. What's the most I can take out? Yeah.
4.
4, which is what? 7 times 4?
Is 28.
Is 28. So the 4 would go right there. 7 times 4 is 28. I'm going to subtract. What do we get when we subtract? We might not know that right off. Yes, it is 6. But you can do the kind of regular subtraction up in there with the borrowing. 14 take away 8 is 6. Okay, bring that 8 down. We've got 68. How many 7s can I get out of 68? What's
9.
the most 7s I can get out? Yeah.
9.
What is 7 times 9? Okay, so 7 times 9 is 63, and we subtract that and get 5. We bring down the next digit, 2. What's the most 7s I can get out of 52? This is really making you think about your 7s today. What's the most 7s? Well, I know 7 times 4 is 28. I need to keep going. I know 7 times 9 is 63. I know that's too big. So somewhere between 4 and 9 is my number. Okay? Yeah.
7.
What is 7 times 7?
49.
Okay, that's the closest I can get without it being too big. 7 times 7, because 7 times 8 is 56, so that would be a little too big. 7 times 7 is 49. And when I subtract that, I don't know that immediately, so I've got to do some borrowing here. 12 take away 9 is 3. So that is going to become my remainder. That's a little hard to see. It's 497, remainder 3. So let's check that. Times 7. 7 times 7 is 49. 7 times 9 is 63, plus 4 more is 67. 7 times 4 is 28, plus 6 more would be 34. Plus the 3, which is the remainder. $3,482. Okay. Alright, so that took us a little bit longer, and the main reason there was the sevens. You can, when I give y'all one that has like 2 as the divisor right here, it's like supersonic fast. So we slowed down a little bit on that one, and that's kind of normal, expected. Okay, this we can do without writing anything. So the top needs to be on your marker. Let's do that for a second. All right, so this is a little mental math here for doing this one. Okay, what would our answer be? One of the hardest things with one of these is knowing what place value to say because of how many zeros there are. So write down your answer. That will make it easier. How about just your answer? Don't write the whole problem. You can do this in your head. Okay. Try not to write the whole problem. Write the answer. How do we do this? Can anybody walk us through what we would do? Charlotte, what would you do first?
You need to do 2 times 4.
You just do 2 times 4 first because of all the zeros. What is 2 times 4, everybody?
8.
8. Now what do you do?
Then you have to add a 0 after 8.
How do I know how many zeros to add?
Because all you gotta do is count
All of them on this side and this side. So I'm going to add 1, 2, 3, 4, 5 zeros. And what I mean is sometimes it's hard to picture how big the number is with that many zeros without writing it down. So there we go. 800,000 would be our answer. You could have pictured that easily and known that answer. But I want you to see you can do these types of problems in your head. Okay? Now I'm going to ask a question. Since we've already done some multiplication and division, let's just talk about this one. I'm sorry that sometimes the pieces get on top of each other, and I didn't go in and move it. But if we were going to find the missing width, I don't know if y'all remember back at the beginning of school, we talked about area and perimeter and how to find it. And this is saying that this is 11. We don't know what this is. They have an X here, and that X just means it's what we don't know. And then they do give us this right here. 99. Remember this square? And they're saying this is miles. So that would be 11 miles. You know, let's say this is a field or something. We're trying to see how big this area of land is. It's 11 miles across here. We know all of this is 99. Well, if that's true, if this is 99, what does this have to be?
9.
Will, what would it be? 9. This would have to be 9 because, remember, length times width is what equals all of this in the middle. So we know 11 times 9 is what makes 99. Okay? Right, again, just put the tops on your markers. Didn't you wonder where that goes? You throw it away. Where is the actual trash can? It's out in cyberspace somewhere. That really bugs me. What does that mean in cyberspace? Okay. For just a second, we're still reviewing. So put your, we're not going to need a marker. We're just more kind of talking together through this. If I put this fraction on the board, okay, I'm sorry, I'm just a little picky today. Here we go. If I put that fraction on the board, what are some other names for that fraction? 1/2 is a fraction that we use a whole lot. We're going to be using it a whole lot more. Okay. So there's a lot of equivalent fractions to 1/2. Okay. There's a lot of equivalent fractions. A lot of fractions that equal 1/2. Now we've learned how to figure this out with multiplication, with division. Of course, we've drawn all kinds of models and stuff too. But can you tell me a fraction that's equal to this one? And that's what I mean by it's another name for this. They equal the same thing. It's just a different fraction. Okay, what's one of them?
4/8.
Okay, 4/8. How did you get there? Okay, he multiplied the numerator and the denominator both by 4 and got 4/8. What's another one? 2/4. And you multiplied both of these by 2. Okay, another one?
3/6.
3/6. You multiplied the numerator and the denominator by 3. That is like a tongue twister. Numerator and denominator, numerator and denominator, numerator and denominator.
Numerator and denominator.
Okay, what's another one?
5/10.
Sure, 5/10. Reagan, did you have a different one? Well, hold on. What did you multiply the numerator and denominator by?
5.
5. Yeah.
8/16.
8/16.
17/18.
You multiplied by. What'd you multiply them by? What did you multiply this and this by to get 8/16? By 8. Yeah.
10/20.
10/20.
Can we keep doing this all day?
Could we keep going and going and going with this? Yes, we could. Okay. Yeah. 100 200ths. Yes. Okay. 11 22seconds.
20 seconds.
Okay. We could keep going and going and going. All of these fractions are equal. Even, look, we can even see it. Okay, you can even see it. All right. I asked you about 1/2, right? Okay. I think most of these are already up there. 2/4. Is that up there?
Yes.
Yeah, 2/4. Okay. All right, you get to go on vacation, dude. All right.
What are you doing here?
What am I doing?
No. Not you.
The pizza?
Yeah.
No, but I need a pan or something. All right, this is 4/8. Is that up there?
Yeah.
Well, what do we do if, okay, like, are there any, oh, that is 6, never mind. 3/6, is that up there?
Yeah.
Yeah, but look at all of our denominators. They're all what?
Different, even.
They're all different. They're all even. What if we have an odd number, like a pizza? Can I have half of a pizza that's cut into thirds?
No.
Not very easily, can I?
No.
Not with an even, not with a, not without cutting one of these pieces. Could I take my pizza cutter and just go right down the middle?
Yeah.
Yes. But if I did that, all of my pieces wouldn't be thirds anymore, would they? I'd have to destroy some of those thirds just a little bit to get the right amount. But what I wanted to show you is in the ones that did have the even denominator, Can you see how they all are the same size? Okay, just with a model. All right, so now that it's going to take me 2 years to get all the
Blah, blah, blah.
pieces back.
Wait, does that mean we won't be in school for 3 years?
What now?
Does that mean we won't be in school for 3 years?
We might need to be so that y'all can go on to the next grade before then. All right.
Wait, we'll be in 6th
Now.
grade.
You have noticed some things about these fractions. All right, what have we noticed so far? You've told me they're all different. So yes, what we mean by that is 1/2 could have many different names. Could be equal to many, many different fractions. So could some of our other fractions. Okay. You also told me that all of these are even. The denominators are all even. Anything else that we notice? Just wanted to talk about that before we get rid of this.
Nope. There's a lot.
Oh, there's a ton more. I mean, we probably would never be able to write them all. Just like numbers go on forever, this could go on forever. Anything else we notice about? Look at those fractions. Anything you can tell us about a fraction that is equal to 1/2? In the coming days, including today, 1/2 is going to be important to us. It's going to be kind of necessary to be able to identify, well, where's the 1/2 mark? Well, what if we don't always have halves? You know, what if 1/2 is where we have tenths or twelfths or eighths? We still need to find the halfway point, okay? And so I want you to become familiar with other forms of 1/2, okay? Look at all of them. One easy, I guess easy. Everybody's different, so I'm trying to give you different things to be able to identify 1/2. If it helps you, look at the two numbers and the relationship between the two numbers. 1 is half of 2. 4 is half of 8. 2 is half of 4. 3 is half of 6. 5 is half of 10. And I think that some of y'all caught on to that, and you were quickly starting to give me more and more towards the end. Oh, 11/22 is 100, 200. You know, make the top number half of what the bottom number is, and so 50/100. So, you know, anything right now to help you be able to see, oh, that's 1/2. That's the same as 1/2. Okay. All right. So we'll keep moving now. We'll go back to our board. Blah, blah, blah. Okay, here we go. All right, so we've got a number line here, and we'll jump into doing some of this on our board in a minute. We've got a number line. We know that we started working with number lines a few days ago. Okay. So they're telling us up here that we're going to be working with sixths. Okay, so I'm going to take my number line, and I'm just going to have you watch right now. I'm going to cut it right about in half, and I'm going to let that help me in a minute. But I'm going to go ahead and cut this into sixths. We're going to start at 0, and we're going to end at 1 today. Tomorrow, our number line is going to grow on us a little bit. Okay? All right. So, we want to become familiar with using the number line. I'm telling you, it's going to be a tool that's going to help us. It's even going to help us when we get to multiplying fractions on down the road. Okay? And it becomes a really easy tool to use. All right. So, if I'm going to cut this into 6, let's do this. All right, now remember, when you are using a number line, what do you count to make sure you have the right number of little divisions? What do you count? I mentioned this the other day. I want to make sure we remember it. Remember it?
You need to count where, like, in between the lines. Not
Yes.
all the lines, like, in between.
Okay. We call these little lines tick marks sometimes. Okay, they're these little short lines that show us, you know, where something is. We count the spaces in between. That's important because if I counted these tick marks, watch what would happen. 1, 2, 3, 4, 5, 6, 7. Okay, I've got to count the spaces in between. Those are my actual pieces. All right. You want to know how many pieces you have, not how many places in between the pieces. Y'all see what I'm saying? Let me pull that apart. I want to know how many pieces I have, not spaces in between. All right, so we have 1, 2, 3, 4, 5, 6. We've got 6. How many sixths equal 1/2? Okay. How many sixths equals 1/2? Will, what would you say? Okay. If this is 0, then this is 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6, which is also equal to 1. I know some people want to do this, 0/6. If you're comfortable, if that makes you more comfortable, you can do that. Some people just automatically, hey, 0/6 means I have nothing at 0. Okay. All right. Will is telling us that right here is our halfway point. That 3 of these need to be, what we need to equal 1/2. Okay. So the question becomes, if this is halfway, okay, y'all stay with me here. If this is halfway, is 2/6 greater than or less than 3/6? Now that may seem like a really simple question right now. We're going to need some of this simple to help us later on. Is 2/6 greater than or less than 3/6? Okay, Valerie, what do you think? If I have 2/6, is this bigger or smaller than 3/6? Smaller. It is smaller. Okay. Why? Why?
Because the numerator is smaller.
Okay, because the numerator is smaller. All right, that could be part of it, but go ahead. Maybe you can add on to that.
It basically shows you on another one. You can see where 3/6 and 2/6.
Okay.
2/6 behind 3/6.
And that's why a lot of people like the number line. If I'm jumping to 3/6, I'm going all the way to here. If I'm jumping to 2/6, I'm only going there. Okay, so you can definitely see with your eyes. Okay, Martin says the numerator is smaller, and he can say that because these two are the what? The same. If we start having two different numbers down there, we've got to be careful about just saying, oh, this is a smaller, this, we got to be careful. Anything else? Any other ways that you might have used to go, oh yeah, 2/6 is smaller than 3/6? Any other thoughts? Yeah.
3/6 is a half.
3/6 is half, and
2/6 is like a 9.
it's, yeah. Okay. All right. Now, without knowing it, y'all are almost creating my lesson for me. Okay, and I'm going to show you that in just a second. Let's answer this question, and you may finish making all my points for me.
Huh?
All right. Is 2/6 greater than or less than 1/2? Actually, we just answered that, didn't we, with Reagan saying that. Okay. Let me show you what I'm talking about. Back before Christmas, we had a 3rd grade fraction lesson. We did that for a while, and I told you guys, this is going to help you so much later on. Please work. Hold on one second. Yeah. All right, maybe this will work. We'll see.
Did you grab one out of it?
Okay. let me write down the reasons you just said. All right. Martin started off by telling us the numerators were the same. No. The numerator was smaller. Okay. I'm trying to see if y'all remember this. Okay. I had a list on the board of about 5 things. 5, 1, 2, 3, 4, 5. Yep, I'll just grab that. Okay. Alright, so give me just a second. I want to get them on the board. Alright. Will, just a second ago, told us basically the number line is showing you that 3, 6 is larger than 2, 6 or 2, 6 is smaller than 3, 6. Okay. The last one that I had on the board before Christmas was this word right here, and Reagan just said, well, 2 6 is smaller than 1 half. Okay. All right. Is anybody back before Christmas? We were looking at 2 fractions, and we were using our thinking skills, our reasoning skills, to tell which one was larger than the other. Okay. And we had all of these ways to think about it. You even had a page to do at home on distance learning that used some of these, if possibly. I told you you might use some of these thoughts. Okay, so this one has a smaller numerator, but these guys, tell me about the denominator there. They're the what?
Same.
Okay, same denominator. If that happens, you're going to look at the numerator. Okay, what was this one? Same what? Y'all remember this?
No.
Same numerator. You're going to look at the denominator. Okay, we used a number line maybe just a little bit. Right, we also would draw a model. We're not doing that one today, but that was part of our list. And benchmarks, and I told you we're going to use this a whole lot later on. Now our benchmarks, guys, that we're going to start using a lot are 0, 1 half, and 1. A benchmark is just like something to guide you. If somebody gives me directions to drive somewhere, to go somewhere, please don't do this. Drive north 3 miles. Turn southeast. Go half a mile. Then turn west. Drive 4 miles. Oh my goodness, I'm lost. But if you tell me, hey, drive down to the Shell gas station, turn right, keep going until you get to the McDonald's, then turn left, go down about 3 houses, you'll see a big tree on the corner, there it is. I like landmarks. I like things like that that guide me. Because I'm just better that way. I know my way that way. That's how benchmarks are. Hey, you've gotten to the 1 half. Hey, you're past the 1. Look at what that means on the number line. Okay? So your benchmarks become like things that kind of guide you so you know where you are. Okay? All right, so without me even telling you, look at all the ones you came up with. Martin mentioned this one.
No, I
Will mentioned, well, you did in a roundabout way. You were looking at the right thing for this. Will was looking at this. Reagan was looking at this one. Okay? Because you guys are using your thinking skills, your reasoning skills. All right? You already have a lot of this up here. I'm just kind of helping you along with it. Okay? So, let's get to a fresh, well, let me stop here for just a second. All right, y'all give me your eyes because once you start seeing what I'm talking about, it really is going to help you, okay? there may come a time when we're given just these two fractions. Okay, guys, which one is bigger? Which one is smaller? And you guys are going to have all these tools, these thinking tools, where you're not going to have to always draw the number line. Sometimes you will. What is 1/2 when it comes to sixths? 3/6. Okay? But I know, what do we know about 2/6? This is 1/2, isn't it? Is this bigger than 1/2? No, because it's only 2 pieces of the 6 pieces. It's smaller than 1/2. And you can almost picture where it's going to fall on the number line. Okay? I think it might help us to go on and hear some different examples. Let's go on to the next slide. Okay. So, we're going to do these steps, but I want you to look at the fractions they're talking about first. They've got 5/8 and they've got 4/8. I'm just writing them bigger right here and just pulling them out of all that. Okay. 5/8, 4/8. What do we know that will help us figure out which one of those is larger? Because the name of the game is comparing fractions. We're trying to see which one is bigger, which one is smaller, or are they equal? What is one way you could think about this? Okay, let's not play right now. Okay. Yeah.
Look at the numerator and you'll see that 5 is bigger than 4.
Okay. If these two are the same, hey, I've got more pieces, more of the pieces that are the same size. Look at the 8s. Okay, we did this before. Do y'all remember us doing this several weeks ago? Okay. If they're all 8s, awesome, because all the pieces are the same size. All right, so that's easy. Which is bigger? 4 of them or 5 of them? 5 of them. Yeah. They're all the same size, so that's an easy one to spot. But let's say you forget that. Let's say you forget that. Okay. What is half when it comes to 8s? What's the halfway point? Yeah. 4/8. Oh, so this is right at 1/2. Is 5 closer to 1 than this? Let's see. Here's 0. Here's 1. Let's put 1/2 right there. Let's cut it in half. Let's make all of our pieces. I know this is 1/2, but it's really 4/8, isn't it? Because these are 8s. Let's do this. All right, that's going to be 4/8, and I'll show that for sure in just a second. All right, so go ahead on your board and create a number line. Turn your board long ways, what we call a landscape. And you're going to cut your number line, or you're going to start your number line at 0 and go to 1. And you're going to divide it into 8s. Go ahead and label the pieces. And I know that your pieces are not going to exactly be perfectly even. You're just going to get them as close as you can. I've got way too many. Cut it in half first. 4 pieces, and you're only going to cut it 3 times. And sometimes you need to double check with your pieces. Do I have 8 pieces? Just count them. 1, 2, 3, 4, 6, 7, 8. You know, count in between the little tick marks. Okay. So how many eighths equals 1/2? I've already said. How many, everybody? 4. So I know 4 of these is equal to 1/2. So is 5/8 more than that? Yes, it is. Okay. Now they're giving us some really easy ones right now. Later on, our fractions are not going to always have the same denominator, and that's where we have to really use a little bit more of our thinking skills. Okay. All right. But can you see how a number line could help you? That is why a number line is on this list. Okay. All right. Let's go ahead and move on to this right here. I think this is where we need to get to. Okay. All right. For now, don't draw this. Go ahead and just put the top on your marker. Okay. We'll start drawing these in just a second. Now this is what we're going to see most of the time, where the denominator isn't the same. Every now and then you go, oh yeah, the denominator is the same. It's not going to happen very often, but it will happen some. But what happens when we have two different denominators then? Oh no, they don't have the same denominator. They don't have the same numerator. I could use a number line. I could draw a model, but our model is the number line right now, okay? I could use benchmarks, okay? Because they've even got 1/2. I know 1/2 is a benchmark, so how could I think through this? Okay, we know where this falls, pretty much. What do I know about 2/3? What do I know? Yeah.
2/3 cannot equal 1/2. So it has
Right.
to be more.
Okay. 2/3 can't equal 1/2 because there's no way to get from 3 to 2 and 2 to 1 by multiplying or dividing the same number. Okay. How do you know that's more than half? How do we know 2/3 is more than half? Yeah.
It's an odd number, so you cannot cut it in half. So you have to take 1/3 and look at half of one.
Yeah, that wouldn't work, would it? Okay. Is 2/3 closer to 1 or is it closer to 1/2? We're not sure. Let's use the number line to help us. Okay. So let's all draw a number line and we're going to cut it into thirds. We are going to start with 0. We are going to end with 1, and then we're going to cut it into 3 pieces. So if you're making 3 pieces, you only need to cut the line twice. And that's after you've made your 0 and your 1. Go ahead and label those. We've got 1/3, 2/3. So we see where 2/3 is on the number line. Does it go past 1/2? Yeah, if we had 1/2 on the number line, it would be right about there, wouldn't it? Okay. If somebody just folded up and chopped our number line in half, that's about where they would cut it. Look at where 2/3 is. 2/3 is all the way right here. We went 1/3, 2/3. We went past halfway, didn't we? We're closer. We're getting closer to 1 almost. Okay. So 2/3 is definitely bigger. So on that one, our benchmarks and our number line help us. All right, what questions do you have for me? I'm kind of getting that blank look. I think this will get clearer the more we do this. You've just, you've just got to see lots of examples of this before it really clicks. What about here? All right, go ahead and change your number line to fifths. We're going to be doing a lot of number line drawing in case we haven't picked up on that. So we'd label these. How many fifths does it take to get to halfway? If this, guys, remember, this whole all the way from 0 to 1 is one whole. How many fifths does it take to get halfway? That's not an easy question, is it? You can't get halfway. Not without cutting one of your fifths in half. So really, 2.5 fifths makes halfway. Okay? So if halfway is right here, if that's 1/2, are y'all looking right here for a second? Let's say that's 1/2. Okay. Is 2/5 larger than half or smaller than half? Smaller than half. So 2/5 is smaller than 1/2. 1/2 is larger. Okay. So right now we're really kind of relying on the number line. We're also letting that 1/2 spot help us. All right, I'm not ready for us to go to that one yet. Okay, let's take a detour. Okay. All right, let's say we have just lay a marker down for a second. We're not going to draw these. Okay, just lay it down. We'll jump back into drawing number lines in just a second. Let's say I have these two fractions. Okay. What do I know about 7/8? Let's use our thinking skills here. Think about, picture it on the number line. What do I know about 7/8? Yeah.
That's bigger than 1/2.
That it's barely what?
Bigger than 1/2.
It's bigger than 1/2. How much is 1/2 when I have eighths? How much is 1/2 when I have eighths? Yeah. 4 of them. 4/8 is half. If I've got 7/8, I'm way past half, aren't I? I'm almost to 1. Guys, if I've got 7/8, I'm just 1 away from 1. Right? Now here's the number line. This was eighths. Okay, that's the 1. This is the 0. 1, 2, 3, 4, 5, 6, 7, 8. 4/8 is right here in the middle. 5, 6. This is 7/8 right here. I'm just 1/8 away from having one whole. Okay. What about 2/4? What do we know about 2/4? Think about it. I know, but I need everybody in the room thinking about it. Oops. 2/4 should kind of jump off the page and be waving at you because it's got another few thousand million other names. Honest, ma'am. What do we think? So y'all are just too sleepy in here. I'm just too sleepy. Okay, let me ask it this way. Just raise your hands for a second. Okay? Because some of you are seeing it, and most of us are sleepy, and a lot of us are letting the others that see it just answer for us, and we're not caring right now. You need to care about this. Okay? If I've got fourths, my number line's cut into fourths, and I'm at the second one. I've gotten to 1/4 and then to 2/4. Where about am I on that number line? Am I near the beginning? Am I somewhere in the middle? Or am I closer to the end, closer to the one whole? Yeah. What? Closer to the end? I'm really not. Mason, what am I? I'm right in the middle. 2/4 is equal to what, everybody? 1/2. Okay? If I know this is 1/2, and I know this is way beyond 1/2, if I can reason that, I don't have to draw a number line. Bam. Okay? Now, there may be times where you already know that, but the directions ask you to draw a number line. Just do it. Good practice. Okay? All right, let's try just another one or two like that. What if we have, no, let me change that. What if we have this, and we have the bubble there, and we have something like this? Okay? Let's think about this. If you have to, picture that number line. If I have a number line that's cut into 6, and it only goes to 1/6. If I have a number line that's cut into fourths, and it goes to 3/4. Which one of those is going to be larger? Oh, the 3 pieces bigger than 1. Not always. These are different size pieces. Be careful. What do you think? You think 1/6 is bigger or small? Bigger. Okay. Now, this is only going to the 1 on the 6-piece number line, and this is going to the 3 on the 4-piece number line. Okay. All right. Plus, these are 6. These are 4ths. Okay. All right. Will, what do you want to say?
3/4 is bigger than 1/6 because 1/6 has small pieces.
Okay. Smaller pieces, and there's not that many of them. Bigger pieces, more of them. Okay, so if this was cut into 6, 1/6 is right here. If this is cut into fourths, 3/4 is right here. Okay, this is not even close to 1/2. This is past 1/2. Okay. Especially if the denominators are even, you can kind of quickly think what 1/2 is. 1/2 is 3/6 right there. 1/2 here is 2/4. This is smaller than 1/2. This is larger than 1/2. Okay. Now, do we always have to just think? Isn't there a way with numbers we can work this out? Yes. It's coming later. Okay. In fact, y'all have already learned. Haven't y'all already learned? Well, let me not go there. We'll get there. Okay. But we're going to get there where there's a number way to figure this out. Okay. But when we get there, there's going to be a mixture of problems where sometimes you don't even have to work it out with numbers. You can see it immediately without having to work it out with numbers. Does that make sense? Because if you can figure this out without working it out with numbers, good for you. You're using your reasoning skills. Okay? So that's what we're practicing today and tomorrow. It's just thinking through some of these types of problems. Okay. We're going to do a couple other practices before we get to our problem set. Let me go back. Stay with me. Now, if you feel confused right now, stay with me. This is one of, like anything else we do. We start off, we practice it, it gets better. All right, here is a number line, and they have given us our 3 benchmarks. We've got 0, 1/2, and 1. All right, and they tell us to plot these points. How many of you, well, we might not have done this enough yet for you to have an opinion. There are times where we get one number line, and they want us to put all different size pieces on the same number line. Some of you would probably rather have 3 different number lines and lay them all right beside each other so it's easier to see. I'm not going to tell you there's a right or wrong way. There's nothing wrong with doing it either way. Okay? I am going to show you very quickly both ways. It does not matter to me which way you choose. Could it take longer to draw 3 different number lines? Yes, but it could be way less confusing. Okay? All right. How about y'all watch this first one? And then maybe we do the 3 number lines together. This is why. When you guys are drawing with a big fat marker like this on here, it is really hard to write as small as you need to write, and then it gets jumbled together and hard to read. And I don't like that for your sake. When you have a pencil and paper, it's a whole lot easier to do this method. Okay? So plot these points. They want us to put 5/12. Now, I'm going to do it up here as long as you are watching and with me. If you're not, then we are definitely going to get busy working together here. If I'm going to make this into 12ths, I need a pen, first of all. All right, so that means, what is half when I've got 12ths? 6/12. So 6/12 is my halfway point. Okay, let's leave everything alone right now. I need your eyes up here. I know that I'm going to have 6 pieces over here. 1, 2, 3, 4, 5, 6. 1, 2. Goodness. 1, 2, 3, 4, 5, 6. All right, 6 and 6 is 12. Okay, so 5/12. I'm not going to write every 1/12, 2/12, 3/12, 4. I could, but I would have so many fractions squeezed in there if I'm doing 3 different ones of these. I'm going to find the one that I need. And I'm also going to, I wrote this one because it's like my guide. It's my benchmark. So this one is the 5/12. Y'all see how I did that? I cut it into 12ths. I just counted to get to the 5/12. Okay. All right, I need 7/8. Y'all also don't have the ability, some of you do, but a lot of you don't, to change colors. It's a lot easier to see when you change colors. It's not easy when you don't. All right, so if this is 8ths, we're going to have to picture this all together. If it's 8ths, what's my halfway point? 4/8. So this is also going to be 4/8. Okay. 8ths would have 4 pieces on both sides. Goodness, this gets hard to see, doesn't it? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So 7/8 would be, here's 4, 5, 6, 7. This is going to be where 7/8 is. Now see how I did that? It's hard though because I've got all those lines in my way. Okay, 2/6. I'm going to add that now. Really? Please go back. how is it here and not here?
Do 5/12.
Okay. Y'all can still see where they are though. There's 7/8, there's 5/12. That's what's important. All right. Let me switch to green. If this were sixths, what's my halfway point? What's half when I have sixths? What's half of 6? 3. So 3/6 is halfway. I'll squish that up here. 3/6. So with 6, I have 3 pieces on each side of half. So that would be about here and here and here and here. Kind of helps that those lines shifted down, I guess. So 2 of those 6 would be right here. 2, 6. Okay. I know that was a little bit of work, but I just created a tool to answer a bunch of questions. Okay? Because sometimes your problem set will ask you to do this, and then they'll give you all these questions like, they'll say, all right, 2/6 and 7/8. Which one is bigger? Well, look at your number line. We got 2/6 here. We got 7/8 here. Y'all know the more we travel this way, the bigger we get. Okay? So which one is bigger? 7/8. All right, I want somebody right now. I just showed you with the number line how to do that. But I want somebody right now to tell me a way to figure out this problem without the number line. Who could do that? Talk us through that with your reasoning skills. Okay, talk us through it. Reagan, talk us through it.
So I would look at the denominator and I would say which one was smaller because the smaller the pieces.
Okay, so these are smaller.
And the numerator, the 7's bigger.
Okay.
So
So you might look at the size of the pieces. That's how you would reason. What's another way to reason? Yeah.
I look at 7/8, and I know 8/8 equals 1, so it's only 1 away from
Okay.
1, and 2/6 still has a long way to go to get to 1. So
Okay.
I look at 7/8 was bigger.
So you used your benchmark thinking. Oh, this one's almost to 1. This one's way far away from 1. Okay? Any other thoughts? Yes.
you can think of like 1/3 or equal to 2/6.
Okay.
So you can think of that and like then you can think that if 3/6 is bigger than 2/8.
Okay. Okay. Are you using a benchmark there, or you just changed it to an equivalent fraction? Okay, so that's not even up here, but it's another way to think through it. You know what I would have used? Anybody else have a thought? All good thoughts, all good thinking. I would have used the 1/2 benchmark. This is why. I know 2/6 is smaller than 1/2 because 3/6 is 1/2. I know 7/8 bigger than 1/2 because 4/8 is 1/2. Okay, if this is bigger than 1/2 and this is smaller than 1/2, then you know 7/8 is bigger. So everybody kind of likes a different method better than others sometimes, but we're trying to share some of these methods and thoughts to help somebody, okay? All right. Now, would this have been easier if I'd had an 8th number line and a 12th number line and a 6th number line? Could you still have seen them? Yes, and I think we did one like this, like that, before Christmas. I think we had like 3 number lines and we put them all side by side. Okay, now, I hate erasing this because that was all the work that went with it, but this is what I'm talking about. Sometimes they're going to give us a bunch of these after we've done a bunch of number lines, and those number lines will help us answer the questions. Now, let's answer these without a number line. What if we don't have the number line? We're going to have to do some thinking. Okay? Everybody's top is on their marker. See, there is some writing and drawing that goes with this, but there's also some time to just think. Sometimes we don't give thinking enough credit. Okay? 5/8 and 4/5. If you were asked to write Greater than or less than or equal to. How would you think through this one? If we didn't have a number line. What do you think? Okay, how would you do that? What would you think? Okay, this is 1 away from 5/5. It's 1 away from the whole thing. And what about this one? What's it closer to? Half. What's half with eighths? 4/8. He's saying this is closer to 1/2. This is closer to 1 whole. So he would do this. That right? Anybody agree with that thinking? Disagree? You're like, no way. I didn't remember this. You know, if you think of something that we didn't think of, let us know. What about, and you know what? Never mind. Okay. All right. I forget that I don't have fifths, so there's the time. All right. What about this one? What about this one? All right. Everybody's looking and thinking. Everybody's choosing some way to think through this. Okay. 2/5, 6/10. One lonely hand is raised. Okay. Now you might have a thought, you're just not raising your hand. It's okay. What are some thoughts here? Will, what is your thought on this one?
6/10 is greater than 1/2.
Okay.
And then 2 like.
It's hard when it's an odd number. Do you think this is bigger or smaller than 1/2?
Smaller.
It is smaller because 2.5 fifths would be half. So you're right. I mean, this is smaller than 1/2. This is greater than 1/2. So which one's larger?
6/10.
Yeah. Okay. Yes. Okay. It gets trickier when they're kind of close together. Ishmael, are we moving here? Is that what you're raising your hand about? Okay. What is your thought here?
2/3 is greater than 3300.
Okay. He thinks this is bigger. Can you tell us why you think that?
Closer to the whole.
This is closer to 1 whole. It's just 1 away from 1 whole. Anybody agree with that? I see some agreement with that thinking. What about this? What do we know? Come on, we know some stuff here. Yeah.
It's not even to the halfway mark.
It's not even to half.
Very, very little.
What is half when it comes to 100? Everybody. 50. So this is smaller than 1/2. This is bigger than 1/2. So you see how we can start thinking through that without having to draw something. Okay. Okay. All right, this is what we call reasoning, and it works most of the time. There are times when we think through it, and we might be just slightly off, and that's when the fractions are very close together. All right, so they've gotten us to our problem set. I think let's take a break. We'll come back and walk through this, but we're basically going to be putting numbers or fractions on a number line and then comparing them with each other, okay? All right, using our reasoning skills. So let me turn this off. Y'all go ahead and mask it, or go ahead and put your boards away, put your mask on, and then line up.